Hello students, this is Dr. Prakash Patoda from St. Mary's ICSE, Masgaon, Mumbai. In this session, we'll be learning how to use double dimensional array to add values of rows, columns, diagonals, etc. So let us recap what we have learned in part 1 and part 2. In part 2 especially, we started learning how to read an array. So when a value is stored, you can see this particular line, first line, int a is equal to the box bracket and the data items are given. These values will be stored in an array somewhat like this, where of course there won't be any color, and of course there won't be any borders as well, but we have to assume that the data will be in a tabular form. And what we also have to understand is these data which are mentioned over here will be having corresponding cell values as what is mentioned here, like 00, 01, 02, 03, 10, 11, 12, 13, and so on and so forth. Now, if I want to read each and every value, then I have to make computer read through its array. We have learned how to read in our part 1 in array A of RC. So R and C will definitely apply some value from the loop. So assuming that R and C is applying 0 and 1, then in this case 0 and 1 is here, corresponding value 16 will be read. Print statement's job is to print on the screen. So like that, because it's a nested loop, of course you need to go through the nested loop again in case you've not understood the nested loop. In the nested loop, we've learned how this is going to generate the rows and the columns put together as this. You can say 0, 0, 0, 1, 0, 2, 0, 3, 1, 0, 1, 1, 1, 2, 1, 3, and so on. And if you look at these numbers, they are absolutely corresponding to the values which are given here. So obviously when these values are going to be applied here, computer will automatically take these values and computer will correspondingly read these values and print them on the screen. This is what we have done in our previous class. In case you do not understand, please refer to part 2 video and then let's go ahead from here. So our next point is how to add rows first. So we are going to take one row and then we will have to learn to apply the same rule into another row. So let us assume here that the row is first row is here. So in first row you got 4, 1, 5 and 6 to be added. Now you have an array, both the sides you can see these are the two methods that we have. First, but before getting to these methods, let us understand that if I have to add these values, it's not the value, but it's the data array cell number is important for us. So being a programmer, you need to focus on the array cell number. Computer will pick up the value automatically. So we need computer to apply 0, 0. You can see here 0, 0, 0, 1, 0, 2, 0, 3. So we need to generate using some loop method these set of values 0, 0, 0, 1, 0, 2, 0. Now there are two methods to this. First method is a very simple method here. If I see here, then my left hand side, the row side is constant, which is 0, and my column side, which is 0, 1, 2, 3, 4. So I'm going to generate a loop to get 0, 1, 2, 3, 4. You can see here c is equal to 0, c less than equal to 3, c plus plus. We know this is going to generate 0 to 3 numbers, which computer will apply here every time the loop will get repeated, and 0 will remain constant. So this is printing. We are going to learn how to add in the practical program. Okay, so we need an accumulator being applied over here. The important part for a programmer to understand is how to ensure that computer will read this value. Now if I apply the method that we have already learned on how to read the entire array, then of course we have a nested loop which is going to help us reading the entire array. But if you now again come back and watch into this table, then you will realize this is the only row in the row number is 0, 0, 0, 0. Rest all the places it is either 1 or 2 or 3. So what you're going to do here is that you're going to generate your double loop, but you're going to write down a condition here if only when the row value is 0, that is R. R is generating row because we are writing here in the first place. Remember, what is written here is counted as row number, not because it's R. It could be any variable. Some people use I and J, some people use I and X. So it is not necessary that it has to be row means R. It's just because here the row is the loop is generating R, so we apply. So whatever is written here is considered as R, and whatever is written here is considered as column. So because I am going to apply this here, so I say if whenever the R value is 0, we will use that particular thing for print or we can also apply for any kind of a calculation. Okay, so let us go to the you can say practical aspect of it. So I'm going to take you to the practical aspect. We're going to start with row number 1 first. So here you can see this, the entire array is mentioned over here, and this time I'm not going to print, but I'm going to add it. So on this, in this place previously there was a print statement. If you see here, in this case there is a print statement mentioned over here. Okay, whereas now we are going to add. So for addition, you know that you need an accumulator which needs to be defined as 0. You can also refer to the accumulation video separately, which if you can go through you can say channel and find out where is the accumulation video. This is how we can accumulate the value. So every value that is generated by the computer will be now added. So again, here we have got the array number. I have just mentioned here for the understanding, row 0 1 to 3, and each row will have 0 1 to 3 column number as well, and these are the corresponding values. So now generation of 0 to 3, 0 to 3. All right, so whenever the R value, because it's written here as R, is 0, computer will find the sum. Now we know this, first first R 0 0 0 0 is 4. So assuming that now computer is going to run, so first value computer will apply 0. Okay, here also computer, for the moment we know, we have seen in the last class, the moment computer will come into the loop, C loop, computer must finish 0 to 3 in order to reach to the next line. So 0 to 3 means computer will apply 0 1 to 3, but at the same time the R value, which is 0 in the beginning here, which is going to remain 0. So 0 0 0 1 0 2 0 3, and in all cases R is 0, so computer is going to add. So assuming that will be a total over here, so first time computer will apply 4 0 0. So first value of sum, which is 0, 0 plus 4 is going to be now 4. So in your computer, sum value is stored as 4 now. When the loop repeats, C value is going to be applying 1. So 0 1, 0 1 is 1. Previous value of sum is already stored as 4. 4 plus A of 0 1, which is 1. Computer will override and make it to 5. The loop repeats, and you will find computer will now apply A of 0 2. So 0 2 value you can see here is 5. So computer already has some value as 5, plus this one's value is 5. So computer is going to make this to 10. The moment computer will repeat this loop from here to here, the value of C is going to be 3. 0 3. 0 3 is going to read 6. Some value is already 10, plus 6 will become 16. So now computer will repeat the loop. Of course, C value is now already crossed 3. So pointer will come here. The value of R is 1. Now value of R is going to be 1 2 3, correspondingly 0 1 2 3. But in all cases, R is not 0. So computer will not follow this condition. And at the end, computer pointer will come out to print the value of sum, which is supposed to be 16. So if I compile this program, which shows me no syntax error, and I run this program. Yeah. And my answer is giving first column row values is equal to 0. Now the same program, if I want, I can also apply using this method. You can see this method here. Now I'm generating still 0 0 0 1 0 2. If you see here, I have shown you 0 0 0 1 0 t. So 0 is constant, 1 2 3 needs to be generated. So computer will generate in the form of C. 0 to 3 apply here, this will remain constant. So 0 0 0 1 0 2 0 3. Now again 0 0 0 1 0 2 0 3, 4 1 5 6 will be applied onto the sum, and my answer will still come the same. So if I compile here and minimize this, compile, why it's not compiled, let me just see. Sorry, my mistake, row 1 dd. So now by mistake, while copying pasting, I made a mistake. So yeah, I rectified my error, and here we go. So my answer is still 16. Now the same logic is going to be applied on column as well. So if I see a column program, okay, then again here I need a column first. So let us go to the PPT section and see here. I've changed this. Now I want first column. First column is 00102030, 00102030. So now you see the column side which is constant 0, but this is what you have as 0, 1, 2, 3. So I've generated a loop 0 to 3 which I am going to apply here, which will apply 0, 1, 2, 3. At the same time the column side will remain 0. So now it is going to be 0, 0, 1, 0, 2, 0, 3, 0. At the same time you look at the left hand side. This is the only place you will find the column value is 0. Rest all the places either 1, 2, 3. So in that case we have applied here nested loop which is going to read the entire array, but we are giving now a condition that only when the column value is 0 you need to print. Now in this case we are going to learn to find out the sum. So in case of print you will have to apply a print statement along with this. In case of finding the sum you will have to apply the sum accumulator over here. So again we have generated 0 to 3 loop, and whenever there is C is 0 we are going to add it. So only in the case of C column value which is here 4, 5, 1 and 3. So this is the only case it is going to add the value. So first time R value is 0, computer will apply. C value is also 0. So 0, 0, of course 0, 0 is 4. Alright, where C is definitely still 0. So automatically computer will say first value 0 plus 4 will remain 4. So my total will become 4 here. Now once the loop, now we know column value is going to be 1, 2, 3, which is no more 0. So computer pointer will come here taking the next value of R2 1. So computer will apply here 1. But C is again going to begin with 0. So of course here 0. Because C is 0, 1, 0, 5. So computer will apply 1, 0 which is 5. 4 plus 5. 4 is already there. 4 plus 5 will become 9. Okay, now after doing this the value of C is going to be 1, 2, 3 which is no more going to be 0. So the pointer will move from here to here taking the next value of R to 2. So computer will apply here 2. Now this time computer is going to again start with C is equal to 0 which is still 0. So 2, 0, computer will add 1. So there is already 9. 9 plus 1 that is come from here is going to make it to 10. And then the last after this, of course, column values 1, 2, 3 are no more 0, so will not be added. Computer will take my value to 3, apply here 3. But C value will begin with 0 which is 0, so computer will apply here C 3, 0, 3, 0 is 3. So sum which is already given as 10 which is already given as 10. 10 plus 3, 0 which is 3 will make this to 30. Now C value is going to be 1, 2, 3 which is no more 0. Once the loop is over pointer will come here and first column value should come 13. So when I compile this and close and run this program, my answer, okay, let's see why it has come 12. Maybe it is my mistake. 3, 0. So yeah, because I have written here 3 and 0, I should have made it to R, and C. So you see when you are doing this program you have to be careful, otherwise one mistake can lead to a wrong answer. So there we go. I hope we have understood. Now the same thing can be also done with diagonal. Now we will see how to add each diagonal. There are two diagonals we'll have. We can call left diagonal and right diagonal. So you will find this is the left diagonal, this is your right diagonal. Alright. If you're going to have a look at the diagonal, first let's start with the left diagonal which is mentioned over here. Then the corresponding values are here which is 4, 8, 5 and 6. And if you want to add them or you want to print them, then what you need to understand here is to generate these numbers. Now you look at these numbers, then the row number and the column number in all cases is same. Now very important thing that you need to remember is that diagonal question in ICSE also will come only if the array is a perfect square. That is, it will have 4 rows, 4 columns, 5 rows, 5 columns, 3 rows, 3 columns. It cannot come which is not a perfect square, like 4 rows, 3 columns or 3 rows, 4 columns, not possible. Right, so it has to be a perfect square, then only it can be generated. Now you'll have a look at this. The row number and the column number is same. Now in this case what you can do is you can again have two methods over here. one using a single loop, another using a multiple loop. Now we need to know both because they both have their own unique you can say reason. So let's first get into the first one with the help of a program. So I'm going to shift my screen over here and I'm going to take you to the program. So if I'm going to look at the left diagonal, so let us start with here one method. This is a method where you are going to use a single loop. Now in single loop, if you ever look at this, that we have created an array which is again 4 by 4. There are 4 rows, 4 columns, and here this time we are adding it. So what we are doing is whatever you can say the array cell number which is having a same row in the column number like 0 0 1 1 2 2, we are going to add them. So what we have done is we have created one loop because it's same, so it is working with the one loop only. So 0 to 3. Now we know C is going to generate in the loop here the value 0 to 3. Now wherever C is applied, so here being C is applied, so if this is 0, this has to be 0. So A of 0 0, which is going to take this value 4. So 0 plus 4 is going to make it to here 4. Then you will have the loop will repeat when the value of I is going to be 1. This is A of 1 1. So A of 1 1, you will see the value is 8. Now sum is already storing 4. 4 plus 8 is going to become 12. Now the loop will repeat and will apply CS2. So 2 2. A of 2 2. A of 2 2 is 1. So sum is already holding 12. 12 plus 1 will become 13. Now after this the loop is going to convert into 4. C is going to be 4 because the last value was 2. 2 plus 1 is 3. So computer is going to apply 3 and 3 over here. So row number 3 3 is going to be 6. So 13 plus 6 is going to be 19. So you will find when I am going to run this program, your answer is going to come 19. So let us see, compile here, which shows no syntax error. I'm going to run this program. So I'll close this. I'm going to right click on this and say void main. Now you can have a look at this. The sum value is given as 19. Now the same program can be done also using double loop, nested loop. A nested loop is a loop that will help you to read the entire array. So entire array we are going from 0 to 3 for rows. So outer loop, 0 to 3 for columns. For each time is your inner loop. Now what we are doing is we are instructing a computer by writing a condition that whenever there is a row and the column same, you only add that place. Now we know that row and column is only at this place, then it is going to be at this place, and then it is going to be at this place. Okay, and it's going to be at this place. So my total will still come same. Okay, this is something I must have been teaching something else. Okay, and my output is, so if I'm going to compile this and run this program, your answer remains the same. So I hope you've understood both the methods, single loop and double loop. Now let us move on to understand the right diagonal. The right diagonal is little tricky or dicey. Lot of children make a mistake here, so kindly pay attention. Now in right diagonal, if you have a look at this, that both the values, the row and the column, they are going exactly opposite to each other. When they go opposite to each other, you can't take one nested loop having two loops together, one going against each other, then you will end up getting again the same thing whole array. Alright, here you will have to ensure that one of them will be a loop and another is going to be probably a counter. That is option 1. Okay, the second option that you will always see here is your sum of the row and the column. If you add 3 and 0 is 3, 2 and 1 is also 3, 1 and 2 is also 3, 0 and 3 is also 3. This is the only place you will find sum of the row and the column is the value of the last either column or a row. So if there is a 5 by 5 array, then the last column number and row number will be 4, 0 to 4. Then your sum will be 4. Okay, so you need to understand in no other place the total will come out to be 3. It will always be less than 3 or greater than 3, but never be 3 when there are 4 rows and 4 columns. There are 4 rows, 4 columns, so obviously they are numbered as 0 to 3, so the last value is 3, so sum is always going to be 3. So again, this is done in two ways. One is using single loop and one is using double loop. So let us go and check our program. So I'm going to take you here and let us start with the first, like last time we finished with the nested loop. So I'll begin with the nested loop. So here is my loop array. I'm reading the entire array by using this nested loop. Now I know computer is going to read the entire array, but I'm also writing a condition whenever the row and the column total will be 3. Why 3? Because this is 0 to 3. So the last value, that is 3, even in this case is 3. Okay, so automatically then computer will apply that, and that will be my sum. So let us run this part of the program. So in computer, in row is going to pick up 0, whereas column is going to start with 0 first. So column will be applied here is 0 0. So sum of a 0 0 is going to be applied 4. But then computer will check, is first value is 0 and this is 0, is it same? Yeah, no. So it is not same. That total 0 plus 0 is equal to 3. No. So pointer will move and take the value of C to 1. R is still 0. Okay, R is still 0. So if I delete this for the time being, R is still 0. My C is 1. 0 plus 1 is 3, false. So comes here. The next value of C is going to be 2. So 0 plus 2 is also false. 0 plus 2 is equal to 3 is also false. Pointer comes here. Now the last value of column is 3. So R is 0, C is 3. 0 plus 3 is equal to 3, true. So 0 3. Your 0 3 is 6. So computer will apply nothing plus 6. First time some value is 0. This is of course not supposed to be here. So 0 plus 6 is going to be 6. Now the loop is over here because I finished with all the values of C. So computer will take the next value of R as 1. So this time I'm going to be applying 1. So it's going to be applied here as 1. So again, when after this my computer pointer will come inside, it will start a C value with 0. So now it is 1 0. 1 plus 0 is equal to 3, false. Comes here, next value computer applies 2. 1 plus 2 is equal to 3 is true. So 1 2 in array row number 1, column number 2, 6 is picked up here. Previous value is also 6. 6 plus 6 is 12. So computer has added 12 now. Now obviously after this the value of what do you call the you can say column is going to be now 3. So 1 3 1 3 1 plus 3 is equal to 4 is going to be false. So the pointer comes here. Now the next value of R is going to be 2. So computer is going to begin with 2, but column is going to begin again with 0. So 2 0. So computer is going to be apply here 2, here going to be 0. 2 0. 2 plus 0 is equal to 3 is false. So the pointer comes here. Okay, so I'll keep it here 2. Now computer is going to say 2 1. 2 plus 1 is equal to 3, which is true. So 2 1. 2 1 is 1. So computer is going to apply here 12 plus 2 1 is 1, so becomes 13. The loop continues. 2 3, which is 2 plus 3 is equal to 5 equal to 3 is false. So computer pointer will come from here to here and takes the next value of the last value of CR is 3. When this is 3, again we begin with 0. So computer is going to apply 3 over here, but this is going to be 0 in first case. 3 plus 0 is 3. So computer is going to apply 3 0, which is 3. Computer is applying 13 plus this value 3 will become 16. Now of course 3 1 3 2 and 3 3, their total will not be 3. So pointer is over and computer is going to come out of the loop. So let us see whether I'm getting my answer over here. So I'm going to run this program and I'm going to show you here. Okay, let us see where it made a mistake. I have made a mistake over here by writing here. I should have written here R and I should have written here C. So you need to be careful when you are testing and trying that all variables are in its place. So there we are. I got my answer. Sum of diagonal, right diagonal is 16 rather. Now the same program can be done using single loop. In single loop, what we are going to do is we are going to generate a reverse loop You can generate a forward loop also. We are generating a reverse loop which we are going to apply here. So logically this is going to be 3 2 1 0. At the same time, when this is going reverse, I have already taken x value as 0. So computer is going to apply 0, in the memory will become 1. So next time computer will apply 1, memory will become 2. Next time computer will apply 2, memory will become 3, and so forth. So this is 3 0, then 2 1, then 1 2, and probably you can say 0 3. So this is going to generate the reverse loop. So I'm going to write down here the reverse loop: 3 2 1 and 0. This is going to be my loop, and this is going to be my x. So I'm going to write down x is going to have first time 0, then 1, then 2, and then 3. So 3 0 2 1 1 2 and 0 3. You can see these are going to be added. So my answer should be same as what my previous answer is, which is 16. So I got my answer. I hope you guys have understood this you can say explanation, which will add the rows and the columns. Now what we are going to learn here is the reason behind learning the nested loop. So I'm going to now mix up everything to show you that the sum of both the diagonals. If I have to show the sum of both the diagonals, then I need to combine both the program. I don't need to write two separate programs. Suppose you've been asked, find out sum of left diagonal and right diagonal, then you need to take another class. So let's say I'm going to take another class and I'm saying both diagonal. Okay, and I'm going to create a class. Here is my class. What I'm going to do is I'm going to take my right diagonal and I'm going to first copy this. Okay, I'm going to copy this. So I'm going to come here and I'm going to copy here, paste it over here, and of course I'm going to rename here as both the diagonals. So I'm going to say both diagonal. Okay, now this is already there. I just have to add from my previous, because if you have a look at this, okay, if I minimize this and I come here my left diagonal, I still have the same loop. My loop did not change. So if you look at this both diagonal, my already right diagonal values is here. In my left diagonal, the loop did not change. So I'm not going to repeat the loop. I'm only going to write this condition. So I'm going to say copy from here and I'm going to probably paste it over here. So I'm going to write down over here, paste it. So only when r plus c is equal to 3, it will be added. So as when r is equal to c, it will be added. Now what I have to do here is I can't have both the sum as the same variable. So I'm going to declare another variable. So this time we are going to make a variable int, let's say diagonal, this being a left diagonal. So I'm going to say diagonal 1, and I'm going to make this as a diagonal 2, diagonal 2. So I'm going to write down here also is equal to 0. Okay, and here I'm going to say diagonal 2 is equal to diagonal 2 plus the value, and here I'm going to say diagonal 1 plus diagonal 1 is equal to so and so. I can write them exchange this both the places. It doesn't matter. All right, as long as the condition is true, computer will follow this. Now I need to also print. Now this being my right diagonal, I have to print d2. Now I'm going to also copy from here my left diagonal line, and I'm going to say copy, and I'm going to say paste over here. So I'm going to paste it before my left, right. I'm going to write here, and I'm going to change this to d1. Okay, so now you can see that in the same program I'll be able to do both the diagonals. You can also do the rows as well, but we will see that in some other class. Right now I'm compiling and I'm going to close this program. Okay, and I'm going to run this both the diagonals. Then I'm getting answer to both the diagonals. Now you can see why they have come in the same line, because it is a print statement. You can see, so we will make it to print ln statement in both the cases. Second can be print, but doesn't matter. And I compile this program and I'm going to close this, run this answer. So I hope you guys have understood how to add both the diagonals and the rows and the columns in this particular session. So I'm going to stop here with my session. Okay, this is what we have done with the help of a program. So this is the explanation about how both of them are writing simultaneously given to u, one single loop, another is a nested loop. This is for r is equal to c, it is for the left diagonal, and here is a uh, the program is, I think I missed out on the previous program, so let us go back and check it out whether no, I don't think so I have this program in this session. You can always take this program from my already program from the BlueG. Meanwhile, thank you very much, God bless. I hope you guys have understood